So what we're going to look at in this tutorial is this PDF file that's available on Shoespace, and in this tutorial we're going to look at the repair of an imported IGES format file. So IGES format is a neutral CAD format. Almost all CAD systems, all 3D CAD systems can export the IGES format. So it allows cross-compatibility between systems. When you import an IGES file, it won't have any features in the feature tree or the model tree. It's purely the 3D geometry, so it doesn't store any record of how that geometry was created. And specifically what we're going to address in this tutorial is the instance that you've been given an IGES file, maybe from a colleague or an external company or contractor, but the IGES file has become corrupted. So sometimes during the export process from the native CAD file format, when it gets converted to one of these neutral formats, sometimes pieces of geometry are lost, or pieces of geometry will extend themselves beyond the part, and that's what's happened here. So we're going to learn a little bit about how to repair those errors and how to get the geometry back into a usable form, so that you can use it to continue the modeling process or use that geometry for machining purposes, let's say, or as the basis of your next model. So let's get rid of the PDF for a second. As I say, the PDF can be downloaded from Shoespace. You're also going to need to download the IGES file from there as well. So you can see here that I've downloaded the block.igs file from Shoespace as well. And this is the IGES file that is essentially broken, that we're going to fix now in this tutorial. So there's a couple of ways of opening this file. Probably the easiest way, if you're looking at it in Windows in a folder, you can literally just drag and drop it onto the Creo window. You can also use the open file dialog, but you will have to set the file type to IGES in order for Creo to see the file then. So the drag and drop method is probably the preferred method. All the settings we're going to leave as automatic, and the system's going to name this part file as block by default. So if we OK that, we then get a representation of what the geometry in that file looks like, and I think straight away you can see it's quite obvious that there's some errors in geometry in this file. You can see that what appears to be a solid part is actually just the outer surface, and it's actually hollow. You can see inside this. So in terms of using this to represent a real world part that would have a volume and along with that some mass to it, this is purely just a surface. So we have to do something in order to use this as a solid piece of geometry. So essentially what we're going to look at is correcting these errors. You can see that there's a chamfer on this hole on the top, and one of the surfaces of the chamfer is extended well beyond the top surface. There's a missing surface on the top face here that appears as if it should be there, a flat surface or a planar surface if you like. And then there's a hole down here which appears to be filled on this side but is actually missing on this side, and then there's an overhanging surface here as well. So we're going to repair all these errors and hopefully make this back into a solid piece of geometry that we can then use to go about our activities, either amending it or using it in an assembly. So let's have a quick look at how the tutorial begins. So we've run through task 1 there. We've loaded the IGES file in. This is from a slightly earlier version of Creo. So in past versions you would have got a report. In this version the report has been filed, but it's been saved to the disk as a text file. So you will have to dig around if you want to read the report on the import of that file. So the first thing that we're going to do is we're going to edit the definition of this imported geometry, and you can find the imported geometry in the model tree there. It's just import feature ID 5. Yours may have a different ID, but that's essentially the only piece of geometry that's been imported, so it will be that one at the bottom of the model tree. And we're going to right click on that and edit definition. And then from the next screen, what we want to do is select this this first aid kit option here, and if we hover over it, enter IDD editing environment. That's what we want, and that brings us into a second menu here, which has got lots of tools that allow us to edit the surfaces on this part. And you can see now that if I hover over the individual faces and surfaces, the system is identifying them as individual elements, and that's what we need in order to repair some of these errors. So the first thing that we're going to do, again, if you're following on the tutorial, the wording here is changed slightly, but the tools are still available. All the same tools are still available in this version of Creo. You just have to search around for them a little bit more. So the first thing that we're going to do is repair this hole down at the bottom here. So what you need to do is you need to select the first edge at the top there, and then hold down Control and select the bottom edge. Try that again, hold down Control, make sure you have the two edges selected, and then we're going to put what's known as a boundary blend between these two edges. So here's the boundary blend tool. It's easy to find, and you can see that we get a little preview there of the surface that's going to be created to bridge the gap, and we're happy with that. That's okay. That surface is a flat surface, perfectly flat, because these edges are parallel with each other, and when you viewed from the top, they're coincident as well. So we get a perfectly flat surface, which is what we require, because we can be sure then that it's terminating at the same point as this arced surface here. So it's touching it along its entire length, and also at the other side it'll be touching this surface along its entire length, so we're happy with that. So let's click on OK. You can see the surface has now been created, so we've essentially repaired the first hole in the model, so we can move on with the next task. So the next thing that we're going to look at and try and repair is this overhanging surface here. So you can see, hopefully just using a little bit of logic, that if we compare it with its partner surface on the other side of the part here, it should terminate in line with this front face, and this one doesn't. It runs on past the face. So we're hopefully going to be able to trim it back so it terminates at this edge here. So let's look at the tools that we're going to need. First of all, we're going to select the surface itself, and the tutorial's asking us to find the trim icon. Now that's not readily available up here, but you can find it if you open up this submenu in the edit section here. You can see trim's still there, and the icon for it is still the same as the icon that's shown in the PDF. So again, you just got to dig around for some of these commands. They are all still there, they're just in slightly different menus, or in the ribbon bar somewhere. So essentially what this is asking us to select is another surface or another edge as a reference to trim this surface that we selected first, this large side surface back. So we can select this edge here, and as soon as we do that, we get this preview, which the grid work that you can see there is showing the surfaces that are going to be kept, and then any surfaces that don't have the grid work on are the ones that are going to be trimmed away. So by default the system's picked the correct side of this edge to keep, but let's say it hadn't. We could flip that just using the little reverse direction arrow up here. So you can see as I press that, the pink arrow in the preview section is also flipping. I could also click on the arrow in the display section here, and it just has the same effect. So that selects the sides that you're going to keep and the one that you're going to discard. So we'll click on OK. That's looking good. This side now looks very similar to this side. We've patched the hole there. So the next thing that we're going to address is this chamfer in the top hole here, or this countersink, sorry, in the top hole. Half of the countersink has extended well beyond the top of the part. So essentially we have to trim away all this excess material until this side of the countersink, so this top edge here, is in line with this edge here, which we're assuming represents the top surface of the part. We can check that if we want to. We can go into one of the standard orientations. If we reorient the part, pick this side surface, and then hopefully try that again. Reorient the part, pick the side surface, and then it's just asking for a reference that we want to call the top surface, so let's pick this flat one here. That's good enough for our purposes. So you can see this is where the top of the part would be, and if we change to wireframe, yeah, that's where the countersink should also end. So that's essentially the level that we're going to trim this large cone back to. So let's go back into shading with edges so that we can see what we're doing a little bit easier. And we're going to use the extend command, which seems a little bit counterintuitive, but the extend surface command also allows you to reduce surfaces down. So again, the command's not readily available in the menu up here, but if we go into the edit drop down there, you can see that the extend command is there, extend the edges. So if we pick that and then select the edge that we want to apply it to, which is this edge here, you can see that we now get a drag handle that allows us to quite rightly extend the surface, but also if we drag it negatively we can reduce the surface as well. So you can see the preview there. The section that we're going to keep has got this grid work on, the section that we're going to get rid of has no grid work on it. So that's okay. And what we can do is we can just drag this drag handle so it's more or less in line with this top surface, and then if we zoom in a little bit more, hopefully we should be able to get it to lock itself onto that top edge. So I'm dragging it, you can see it's going in discrete steps now rather than being constantly variable, and if I drag it and let it snap to that discrete step, it will be in line with the top surface. So I can OK that now. Zoom back out again, you can see that these top edges run into one another now. They're on the same plane, and if we zoom in we can verify that. Yeah, they're definitely on the same plane there. So we fixed the countersink. So we'll move on to the next bit of the tutorial. The next bit of the tutorial deals with this face which is missing from the top of the part. So obviously there should be a planar face between all these edges here, just filling the top of the part in, and it should also have a circular section missing in the center to allow this hole to break through. So let's try and create those surfaces now. The first tool we're going to use is the boundary blend tool. So if we pick the boundary blend tool and then select this flat edge here and the corresponding one over at the other side, you want to hold down Control. Hold on a minute. So let's pre-select the edges first. Let's select this one, hold down Control, select this one, make sure you've got them both selected, no other edges, and then select the boundary blend tool. And there you go. Again, it's giving us a preview of the planar surface because these edges are both parallel with each other. If viewed from the side, they're both coincident with each other, so we get this nice flat planar surface. So we're gradually patching the top of this part. So what we're going to do next is we're going to use the boundary blend tool again, but we're going to select this new edge that we've just created, hold down Control, and select this circular edge. So you can see that that forms a boundary there. If we click the boundary blend tool, we get a preview of the surface that's going to be provided. That's good, it's nice and flat. So we've essentially repaired the top. We just now need to recut this hole to allow the countersunk hole to pass through to the outside of the part. So the way that we're going to do that is we're going to use the trim tool again. So let's get the let's select the surface first that we want to trim. So we'll do it in the order of the tutorial. This is the first surface that you're asked to select. So we'll pre-select that. Then the trim command will be available. Select the trim command. And as you can see now, I'm going to use the edge of the hole as the trimming geometry, but the system regards the hole as two arcs rather than a continuous edge. So what that means is we'll select this arc first. You can see from the preview there, it's only going to trim a quarter of this hole away. So we're going to have to repeat this trim operation 4 times to trim away the entirety of the top of the hole. But that's fine. And again, if the direction that it had defaulted to was wrong, so say it was going to keep the center of the hole and discard all this surface, we could just click on this direction arrow and you can see that the gridwork preview there is changing to the surface that we want to keep. So that's fine. So we've trimmed a quarter there. Just repeat the operation again. Pick this top surface, open the edit menu, select the trim command. Now pick this arc, and again it's selected the correct surface that we want to keep. So you can see that we've completed the operations on this half of this top face. We now need to repeat them for this half down here. So select the surface, trim command, select a portion of the hole, check that you're keeping the correct side of the trim, and then we've just got one final one. Select this surface again, trim, and select this line. And again, it's by default it's selected the correct side of the trim line. So that appears as if we've filled in all the holes in the part, all the holes that were there in error, and we've repaired all the surfaces. So let's move on to the next section. In this section, what we're going to do is we're going to merge together all these new surfaces, so these two on the top here, this one, with the existing surfaces that we imported. So we're merging everything together so that the system regards it as one item. And the first one that we're going to do, obviously this was the imported component. These are the surfaces that we've had to either edit or create. So there's this one down here, this one, and this one. And what we need to do is we need to select the import, hold down Control, select one of the other surfaces, and then we're going to merge these together. So we'll just find the merge command. It's over here in the structure subsection of the menu. So we can hit merge. We get a bit of a preview, and then we'll click on OK. So now we have a merge feature, and if we select the merge feature, we get a preview of what's contained within that. So we're going to just repeat this command again. We're going to unify these top surfaces together first. So let's do that. Let's find them in the model tree here. This surface, hold down Control. This surface, merge them together. Yeah, we're getting the gridwork preview, so it's saying it's going to keep all of these. That's good. So again, we've got a merge feature that represents those, and a merge feature that represents the rest of the block. So now what we're going to do is merge these two merge features together. So just select them in the model tree, hit merge, OK, and then we end up with a single feature, which is a single merged feature. So the next bit of the tutorial talks about the fact that this is still just a collection of surfaces, and what we really require is a solid part that you could apply a density to and get a mass value for that. So we need it solid material all the way through, whereas at the moment it's just a collection of surfaces. So the way that we're going to do that, we can quit out of the import data doctor dialog that we're in at the moment, because we've done all our repairs to the part. So let's quit out of that. And again, the feature described in the PDF is still here. It's just been repackaged and renamed slightly. But essentially, we have this part set as a surface at the moment, or a collection of surfaces, and we just need to select this option, import as solid. So we'll select that, and then we can OK that menu. So now we have an imported feature there, and it's a solid body. So we're almost there. The next bit of the tutorial deals with adding some datum planes, because as you can see, the only two features that we have currently are an XYZ coordinate system and the solid geometry. Whereas in most cases, in order to use this part effectively, either as the basis for your modeling, maybe adding features to this, or to use it in an assembly, it's very advantageous to have some datum planes in there. So let's add the datum planes in ourselves. Luckily we have the coordinate system already, so essentially we have an origin point of the X, Y and Z axes, so we can use that as a reference to place our datum planes, because it's always useful to have the datum planes passing through the same point as this base coordinate system. So let's select the coordinate system first, up in the model tree here, and then if we just click this icon, which is plane, which is create a datum plane, and you can see by default it orients itself normal to the X axis, and you can type an offset in there to make the plane move away from the coordinate system, but as we've said, we prefer all the planes to pass through the center of the coordinate system, so we're going to leave that as 0, and we'll OK that one, and then all we do is just repeat that operation twice more. So we'll pick the block, pick the plane. We don't want it to be normal to the X this time, we want to create one of the other planes, so we'll go down to Y. You can see a preview of what it's going to do, so it's normal to the Y axis now, still passing through this center point of the coordinate system. Still, we don't want an offset, we want it to pass through, not to be offset from. And then we'll just do it one more time, and we can put the Z plane in as well. So that's our datum planes. We could rename them. The system by default, when it creates new parts, it has one as front, one as right and one as top. That's not essential, but if you wanted to do that, you could right click on them here and just add the names in, if that makes working with the part easier for you. Another thing that it might be useful to add in, and a feature that you tend to get if you put the holes in yourself using the hole tool, is the holes tend to have a center axis associated with them, so a center axis of the hole. And again, we haven't had the luxury of those features being transferred across in the IGES file, but again we can add them in now ourselves. So just by the plane tool, there's an axis tool which creates a datum axis in the part, and if we select that and then pick one of these arcs on this hole here, so let's pick this top arc, and you can see the axis understands that because this is a portion of a circle, that it will have a center line, and it locks the axis onto that center line. So that's good. We now have an axis in the center of that hole. We can do the same thing with this one down here. Select axis and pick one of the arcs. Again, we could pick the top one, we could pick this one, we could rotate around to the other side of the part and pick that one. As long as it's a portion of a circle and it's anchored to a plane, the axis will understand that it has to be at 90 degrees or normal to the plane, and it will understand where the center point of that arc is. So we've got our two axes. So at that point, that's the end of the tutorial, and essentially what we've created there is we brought some surface data from the IGES file that had holes and errors in the geometry. We've fixed all the geometry. We've converted that surface geometry into a solid part, and then we've added in our datum features that allow us to then use that part further on down the line. And looking at this part, it's some sort of bracket that maybe has a pivoting connection here, so it's likely that it will be used in some form of larger assembly. So you could now start using this part and maybe add in other native Creo parts to it to form the assembly. So that's the end of this tutorial. It recommends that you save your work so that you can return to it later and maybe interrogate some of the skills and features that you've used in there. So yeah, that's a good idea.